And after I do this first part, if it didn't answer your question, ask it again. Okay, so we did like, oh, look, there's a little more than 6 radians in a full circle. And for the most part, I told you guys, like, yeah, that's basically all you need to really know. So I will say that if you are told you are in radians, then just accept that you're in radians. And so a lot of the time, and I forget all the stuff I said yesterday, but a lot of the time, most of the time when you're talking about radians, pi is going to be sitting there looking at you. But that doesn't mean that that's the only time you're dealing with radians. The problem will say, A, in radians. Okay, and so then if they give you 2, then they're not talking about degrees, they're talking about 2 radians. And if you're really up on things, you can think of that picture that we looked at on page 361. But for the most part, you can just be like, okay, sweet, I'm in 2 radians. Okay, so, you know, I am going to tell you some things that you have to remember. And then everything else would be super cool if you remembered it, but like you'll be able to get by pretty good without it. So like if you knew that picture of the radians on page 361, then you're awesome. But I think that's a good enough compliment that you're just awesome. So let's just, so I'm not sure exactly where we are, but I do want you guys to understand your quadrants. And so like I'm looking at 5 to 9 here. And I don't want to do them all, but, you know, we have this picture here with Ben. I told Ben that, like, he was a big hit, and he's very proud of himself for being a big hit. So it is not Photoshopped. That is a true picture of Ben in my camera angle.
Oh, I was so confused how he was there. I didn't realize it was a picture of the board. I don't know.
Did you?
I'm
confused.
Like, how's Ben like in there? I thought you like had like taken a sticker of him and like put it on.
No, Ben's.
I know. I was a little stressed out.
Not everything is completely. Not everything is a deep fake. So, they don't know what they were talking about here. What am I talking about? They don't even know what a 360 dunk is.
What's that?
Emily, I know. We'll talk about it later. We'll talk about it later. Yeah, we'll talk about that. All right. Okay, so, and I forget where I was going with this, but here's knowing your quadrants is going to be very important. And so when what you're doing with radians is saying, and I don't remember how far we got. Did we say it was okay that a full circle is 2 pi, and so that means 2 pi and 360 are the same? Did we get that? And so then a half circle is pi, because that would be 2 pi divided by 2. And so that's the same as 180. And then divide pi by 2, and you get to 90. So pi over 2 is 90. We did all this, right? Mm-hmm. So basically, and again, very important to understand what quadrant you're going to be in for our unit circle when we get there, is you're basically just saying, am I between 0 and pi over 2? Or am I between pi over 2 and pi? Or am I in between pi and 3, pi over 2, etc.? And so all we're talking about here are fraction rules, basically. Okay? So we can do some of these together, but like let's just do 5. So 5a, right, we're looking at pi over 5. So, right, all we want to know is what quadrant we're in. So is pi over 5 bigger than pi over 2? No, it's not. So then we're stuck in here in quadrant 1. Is that okay? Okay, so then the next part is 7 pi over 5. So again, we're just comparing fractions. Is 7 over 5 bigger than 1 over 2? Is 7 over 5 bigger than 5 over 5? Or 1? Yeah. Is 7 over 5 bigger than 3 over 2? No, it's like 1.4 or something. So then like we're down here in this quadrant 3.
So we can plug in can we plug in the fractions into our calculator like if we're not sure?
Totally.
Okay.
Yeah, absolutely. That's the answer. Totally. Yeah, so just remember what you're looking at, right? Like, so 3 over 2 is what you're comparing it to, right? Like, you know, the pi doesn't really make any difference, right? It's just half, full, 3 over 2. Now, of course, they could give you like it could be like 17 pi over 8. And so then that would be a full circle plus a little bit more. So that could totally be something that happens too. So you'd kind of have to subtract a 2 pi away kind of idea. I don't really do that. I usually just spin it and then go a little bit more in my head. Okay, so 5 to 10. Do we want to do any more of those? Right, we're just naming quadrants. Know your quadrants. Is that okay? And then so then 11 to 14, sketch the angle in standard position. And so it's basically the same as the 5 to 10, right? I don't expect you to get 5 pi over 4 exactly, but you should know that you're in the third quadrant. Hopefully, we're going by quarters. So like that's 45 degrees. So I guess I would kind of expect you to kind of get it close since it's just 45 degrees. But so do we want to do one of those, or what do you guys want? Are we okay with that? It's essentially the same thing. Okay. So then I assume we didn't do 15 to 17. Is that correct? All right. So let's look at. I'm going to do 16 because I don't want to take all your enjoyment of math away. And I'm going to try to do this right. That's so close. So why don't we, well, I'll try it anyway. Let's do this right here. All right, so 16, right? We got this going on. And we go around, and we're told that theta is 7 pi over 6. Okay, so it's the same idea as what we started with the question at the beginning. So we want a positive and a negative coterminal angle. So tell me generally what we're going to do. Just like, yeah, we're just subtracting or adding 2 pi because we're spinning a full circle and we want to end up at the same time. So then let's just do it that way, right? So then 7 pi over 6 plus 2 pi, right? If you're good with your fractions, this is a lot easier because this is really 7 pi over 6 plus 12 pi over 6. All right, so that could be a potential one. Of course, you could add 2 pi as many times as you want and you're still correct. How's that? Right, they wanted a positive and negative, right? Okay, so then, oh, look at that. We keep Ben right where he is, and we can move it up. All right, so then really all we're doing then is 7 pi over 6 minus 2 pi. So again, that's 12 pi over 6. So then we're at negative 5 pi over 6. How's that? I just got a common denominator. So, right, 2 over 1 is the same as 12 over 6. And just like what Emily asked at the very beginning, if you subtract 2 pi away and you're looking for your negative one and you don't get a negative, then you got to subtract 2 pi again. Is that okay? I assume that your non-talking is, then it's fine. So you don't have to worry about the radian measure formula today. We'll talk about that tomorrow. The only thing that we're going to worry about right now is converting between the two. And once we're done with this, you should be able to do, I would say, 3 of the 4 IXLs. Does that sound about right? Okay. Huh? You already did? Or you're a champion? Are you a champion? Are you a champion?
He's a champion today. Yeah, that's the joke, Emily.
That's a good question.
You didn't know what a
He can't
360
see
dunk
his
was.
shirt. I don't know, but he just.
All right, so if I'm going in this direction, because I'm going to explain how you're going to memorize what's going on here. Remember, theta is always going to be the angle we're talking about, the measurement of the angle we're talking about. So where I drew that arrow is equivalent to what? What in degrees? 180. And in what is it in radians? Pi. Okay, so are we happy to say that 180 and pi are basically the same thing? Okay, can you accept the fact that when you're multiplying, you're always allowed to multiply anything by 1? And then if you agree with that, can you be fine with saying that if we multiply by 180 over pi, we are actually multiplying by 1? Okay, so then both the radians to degrees and the degrees to radians, we're just multiplying by 1. Okay, and so we're just changing it to the other form. And the way I keep it straight on which one you're going to do is that usually radians have pi in them. And so then we better be canceling our pi by multiplying by 180 over pi, because then that will cancel your pi's. And then you would become in degrees. Okay? And if you're in degrees, you don't have a pi there, and usually your radians do have a pi. So then you're going to multiply by pi over 180. Okay? You are totally welcome to multiply by 360 over 2 pi if you wanted to. Okay? Or pi over 2 over 90 if you're really crazy. Okay? But 180 over pi is the simplest one. Okay? So I do want you to notice that. Oh, well, should we do one, I guess? Let's just do 39A real quick. 39A. 39A is 30 degrees, and we want this in radians. They don't want us to use the calculator, so what are we going to multiply this by? Pi over 180, because we want to get pi in there, and that means we're going to be in radians. That's just a rule of thumb. That's not completely 1,000% true, because you could totally be given 3 and be in radians. Okay, so just be careful. All right, so then this would be 30 pi over 180, but that's pretty ridiculous. Oops, because that reduces to pi over 6. Okay, so if they're saying do not use a calculator, really all they're saying is you better have the symbol pi in your answer. Yep. Yep.
How do you do B for that problem? Because like what I was getting was different than what the back of the book said.
Okay, so then tell me what we're doing.
Because it was finding the radian measure for 150 degrees.
Oh, how's that moving?
Never
Okay.
mind, I figured out what I did.
Oh, okay. Very good.
I put 50 on 150.
Yep. Okay. All right, so let's do 43 then. A. And right, we're going in the opposite direction, right? We got 3 pi over 2. Hopefully we already know what this one is. But if you don't, that's okay, because now we're just going to multiply it by the 180 over pi. And again, the way I remember it is I'm going to degrees, so I'd love that pi to be canceled. Okay, so then the pi's cancel, I don't know, whatever 3 times 180 is. It doesn't really matter because 180 divided by 2 is 90. So, so really this is 3 times 90. So 270 degrees. Is that okay? Okay, so notice that they're saying don't use a calculator because they're saying like 3 times 90 isn't a big deal. But then on the next 2 sections, 47 through 61, right, they're saying round to 3 decimals. Okay, because they're not going to work out nice and pretty necessarily. So on anything that says round to 3 decimals, if you're multiplying by pi, type in pi and let it multiply. Don't use 3.14. Use the pi button and let it do whatever number that it comes out as. Is that enough for today? All right.